Let's talk for just 1 minute before we get into our mole map problems about the basic idea behind what we call dimensional analysis. Dimensional analysis or unit conversion is where we can convert from one unit to another unit by multiplying by a ratio of two things that are equal to one another. As we all know mathematically, for instance, if we take 2 and we multiply 2 by a ratio of 4 divided by 4, then we still end up with 2. And the reason is because any number that is divided by itself, no matter what that number is, any value divided by itself is equal to 1. And any number times 1 is equal to itself. 3.26 times 1 is equal to 3.26, and so on. And so any value divided by itself is equal to 1, and any number multiplied times 1 is equal to the same value that you started with. So that's really the foundation of this thing that we call dimensional analysis. What we do is we take advantage of this fact and multiply by a ratio of two things that are equal to one another, but that are expressed in different units. So for instance, if we're talking about the volume of a gas at standard temperature and pressure, we know that for every 22.4 liters of a gas at standard temperature and pressure, we have 1 mole of that gas. And for every 1 mole of that gas, we have 22.4 liters of that gas. And so, since these two things are equal to one another, 1 mole of that gas at standard temperature and pressure is equal to 22.4 liters. What we have here are ratios of two equalities. Those things are equal to one another. And since they're equal to one another, to multiply by this ratio is going to be equivalent to multiplying by 1. So if I have 44.8 liters and I multiply that by 22.4 liters, for every 1 mole, which as we can see is multiplying by that ratio of two things that are equivalent to one another. It's like multiplying times 1. And since it's like multiplying times 1, I end up with exactly the same thing that I started with. But the liters as a unit cancel, leaving the only unit as moles. And so I'm going to end up with exactly what I started with, but it's going to be expressed in a different unit. And 44.8 divided by 22.4 is equal to 2. And so 2 moles is equal to 44.8 liters in this particular sample or in this particular type of problem. The thing that is interesting about this type of unit conversion problem is that it's not just a chemistry type problem. It can be used in a lot of different things, including in problems from in day-to-day life. For instance, if you were driving to a particular destination on your vacation and you looked on MapQuest or on Google Maps and you found out that your destination was 350 miles away, and you knew that your car would go 25 miles for every 1 gallon of gas, you get your mileage is 25 miles per gallon. Well, you have a ratio of two equivalents. 25 miles will get you will cost you 1 gallon, so to speak, and for every 1 gallon that you use of gasoline, you can drive 25 miles. And so what we have is a ratio of two things that are equal to one another in this context. 1 gallon is equal to 25 miles. 25 miles is equal to 1 gallon. So we can multiply by one of these two ratios, and which one we choose is going to be determined by the units. Let me do it incorrectly first so you can see what I'm saying with that. If I said I get 25 miles for every 1 gallon, if I'm looking at the units, my units do not cancel as I would like for them to. And really what I end up with is a unit of miles times miles, or miles squared, divided by gallons. And miles squared per gallon is not a unit that I'm familiar with, and it certainly isn't a unit that I'm wishing to use in this context. And so let's erase this, and let's use the ratio of two things that are equivalent to one another, but let's invert that ratio, flip it over, where I say, well, for every 25 miles, it's going to take me 1 gallon of gas. And so now when I look at the units, I can see that miles divided by miles makes the miles cancel as a unit. And the unit that I have left is gallons. And if I take 350 and I divide it by 25, it is going to tell me exactly how many gallons it's going to take me to drive that 25 miles. And if I take 350 and punch it into my calculator and divide by 25, it's going to tell me that it's going to take me 14 gallons. And so unless I've got a little bit larger capacity gasoline tank, a little bit larger than 14 gallons, I'm going to be really pushing it to get there on a single tank of gas. But it's going to take me 14 gallons to get there. Well, let's do another problem that is very similar to this. But let's say that instead I wanted to look at how far I can go on one tank of gas. Let's say that my tank will hold 12 gallons. And my car will go 28 miles for every 1 gallon. Or for every 1 gallon, I can drive 28 miles. Well, again, I have two conversion units that I can work with. And I want to multiply by one of those two conversion units. And the one that I want to select is the one that is going to cause the units to cancel. And as I can see, if I take gallons times gallons over miles, the gallons are not going to cancel. What I want to use is this ratio here, 28 miles for every 1 gallon. And so 28 miles for every 1 gallon, 28 miles for every 1 gallon. Now I have units that will cancel. Gallons cancels gallons. The only unit that is left is miles, and that's what I'm looking for, so that's good news to me. And 12 times 28 is going to give to me how many miles I can go on a single tank of gas. And my trusty calculator tells me that 12 times 28 is 336 miles. And so that's how far I can go before I run out of gas. So, to summarize, anytime we multiply by a ratio of two things that are equal to one another, we get the same value as what we started with, but it's expressed in a different unit. And what we do is take advantage of that fact when we want to calculate the number of moles that we have from the mass, or the number of moles that we have from the volume, or the number of moles that we have from the number of particles we have. We can use ratios of two equivalents to be able to convert from one unit to the other. And the link is going to be 6.022 times 10 to the 23rd particles for every 1 mole, if we're talking about particles such as atoms, molecules, or formula units. We're going to be talking about 22.4 liters for every 1 mole if we have a gas at standard temperature and pressure. And we are going to use the molar mass of the substance that we're talking about as the link to get us to moles from mass. For whatever the molar mass is, that's how many grams per mole we have for that substance. And we will talk more about how to calculate molar masses in another video.